Good afternoon, everybody, and welcome to our webinar this afternoon, looking at how to fix your movement in transport challenges. Just wanted to run through the programme today. Myself, Marketing Manager here at Lindum, will be facilitating the event. We've got some of our colleagues and staff speaking today. We've got our Managing Director, Bernard Sellers, who's looking at an introduction to movement in transport. We've got Oliver Giles, who works in business development here at Lindum, looking at some real life scenarios of movement in transport. And moving on to Rick Sellers, who's a packaging technologist with us here, looking at how to identify MIT causes. And we've also got a guest speaker from Crown Paints, Steve Lomax, who will be sharing his experiences of collaboration. So just a bit of housekeeping. There is a questions facility. If you do have any questions throughout the webinar, please feel free to drop them in the questions section. We do have a dedicated slot at the end of the webinar for questions. If you could take your question with your email address, if we run out of time and we don't get a chance to answer your question, we can then email you after the event with the answer to it. So without further ado, I will hand over to Bernard, who will be giving an introduction to movement in transport. So Bernard, over to you.
Thank you, Emily, and good afternoon to everyone who's joined our webinar this afternoon. It's good to see you all virtually. I've been asked to do a brief introduction to movement in transit, or MIT. The fact that we're on this call probably means we don't need much in the way of an introduction. It is an aspect of the supply chain which is a challenge, and it has the potential to be very costly, both financially or indirectly, and to our brand. So the true cost of movement in transport is generally more than we think. There's three well-known aspects. There's the loss of damaged goods, there's transport costs, and there is credits to customers. That's really the tip of the iceberg as we dive a bit deeper into what this challenge is costing our industry. There's brand reputation damage, there's rework of product and packaging, spill and cleanup costs, there's environmental impacts. Think of the CO2 liability by reproducing and remanufacturing products, customer loyalty, customer service time, personal injury, often difficult to quantify but very, very costly, and then the whole impact on supply chain and administration costs. Not an easy calculation to do, but I think we all know in our experience that those costs are there and the impacts are very, very real. So we move on to the next slide. So we thought we'd present some interesting pallet facts. Most goods in the UK are moved by pallet initially. There's about 60 million new wooden pallets produced every year in the UK. There's 150,000 tons of pallet stretch wrap used, and we estimate that there's over 750 million pallet journeys each year in the UK. So pallet stability should clearly be a priority. We've had a look at some of the other statistics around transporting goods by pallet, and some of them are quite frightening, in fact. One person injured or killed every hour in the EU and UK due to insecure cargo. That's a statistic which UMOS publishes on their website. And up to 11% of all palletized goods can arrive at final destination with some damage. The third fact, very interesting one, is that the UK could save 41 million kilograms of plastic stretch film each year whilst fixing MRT issues. This is a calculation that we've made based on work over a number of years with key clients, looking at not only the plastic savings but the MIT resolutions, and basing that across the whole market. We're very confident on that 41 million kgs of plastic to potentially save. I suppose the question today really is, how are you mitigating these risks in your supply chain? We've had a number of aspects, and we will go over some root causes and some solutions, but we wondered if we could just do a poll of our audience to just get a feel for how these issues are affecting you in your business. So the first one is it logistics? or is it storage and handling, your warehousing and handling equipment, or is there issues with your packaging? Maybe if you could just click on the poll and share your thoughts with us, it'll help us get an indication. You got some responses coming in there, Emily?
We do. We've got a split really, 50% packaging, 44% logistics, and 6% storage and handling.
Oh, that's a very, very interesting, and I dare say a typical result of what we would expect. So we package a product and we find challenges, maybe in packaging design, materials, or performance. We find packaging sometimes coming in that is below spec. But we do our best. We pack the products the best we can and we push them out into the supply chain. And an interesting find, the number that feel driver error, poor loading, and bad roads. These are really items that are outside of our control. So maybe we'll move forward and have a look closer at some of those statistics later in the presentation. So I'll hand over now to Oliver. He's in our business development team. He specializes in pallet stability, and he has some real life stories which he would like to share with us. Over to you, Oliver.
Thanks, Bernard. That's some very interesting and slightly worrying statistics you've just shared there. I've got 3 situations that we've come across recently that I wanted to share that I think really bring out some of those statistics that we've just been looking at. The first one is a situation that actually happened to us. It was late one December. We had a truckload of products coming from a manufacturing plant on the other side of Europe, direct to one of our customers in the UK. And this truck, having travelled over 2,000 miles, arrived at its destination, and the driver opened the curtain as normal for preparation for unloading. As he did so, 3 of the pallets collapsed and toppled out of the trailer, and unfortunately knocked him over, crushing him and trapping his leg. Sustained a nasty fracture injury and was subsequently taken to hospital by ambulance. And in the ensuing chaos, it came to light that the keys of his truck were actually in his pocket when he disappeared in the ambulance. So the truck was left blocking a busy loading bay. However, the real cost of this whole incident was that this driver was then unable to get back to his home in Europe to spend Christmas with his wife and family. He was stuck in a hospital in the UK, and this is entirely unacceptable, particularly when you consider that a few extra euros spent on packaging could have prevented the whole thing from happening. And this is just one of the statistics that UMOS tells us about, and they say this kind of incident happens on average once every hour. So the second point I wanted to come on to was just looking at what is the real environmental cost. And this is borne out in some work we did a few months ago with a major food brand in the UK. They originally advised us that they'd fixed their own stability problem. And we noticed while we were doing some work with them that all of the pallets leaving their warehouse were only very short. They were only, I think it was 1.2 meters high, which seemed to us to be a bit unusual because it was only a lightweight boxed product. There was nothing unusual about it that was limiting the amount of goods per pallet. And it turns out that they had been having massive MIT issues. Tall pallets, 1.9 meters high, had been falling over on a regular basis. So what they'd done to address this is they'd reduced the height of the pallet, And this had, in fact, reduced the number of MIT incidents that they'd had. So as far as they were concerned, it was a successful move. However, we started to look at what was the CO2 impact or the CO2 footprint of that product, because we know that everything we do has a CO2 impact. And the carbon footprint of this particular product, I'm just looking at the transport of it from manufacturing sites to the main distribution hub that was about just over 100 kilometers away. That worked out over 430 tons of CO2 in a year. And then we started to dig into it a bit further, and we actually ran through a project to have a look at what could be done. And by changing the stack pattern of the product and improving the transit packaging, we were able to safely increase the load size from 60 boxes per pallet up to 96. And that, in doing so, increased the load utilization of the trucks, which actually reduced the carbon footprint by 39% on that particular product. And this is such a classic example of how an effort to solve an MIT issue was actually completely unsustainable. And it really, to me, it really begs the question, how many other companies are there out there that are currently working around MIT issues at the expense of the environment? Now, the last situation I wanted to share with you was looking at the actual cost of what an MIT issue can be. I was in discussion the other day with a transport manager who is he's the main haulage contractor for a major drinks brand, and he was telling me about one particular product that they were having some issues with. It was a very cheap bottled drink, and the sheer number of MIT issues that he was describing to me was utterly staggering. They were quite literally having full truckloads returned, and they were unable to unload them because all the pallets had collapsed against the truck curtain. And they were physically having to back the truck up to a skip and open the back door with a 10-foot pole, because they knew that as they opened it, goods, bottles, glass, pallets were going to come crashing out. And I asked him, I was a bit intrigued, I asked him about what's the cost of all this. And he said, well, look, it's only a cheap product. We can allow for extra wastage because we know this is happening. But it turns out, when we actually dug into it a little bit deeper, that there was a much more subtle cost, if you like, than just the cost of the product and the cost of the time to clean up all the mess. It was there when we talked to some of their retail customers who were receiving truckloads of this product in. Their teams were actually on the lookout for this product coming in, because in their mind, this particular brand was black marked. They knew it was the ugly duckling to watch out for, and they expected to return 1 in 2 loads. And it really got me thinking about how much movement in transport can have an unknown impact on your brand. And now I very much doubt that the owner of that brand really wanted that kind of message in the mind of his customer. So now I'm going to hand you over to Rick, who's going to be looking at what actually are the root causes of movement in transport. And just a little reminder, if you get any questions as we go through this, please put them in the chat box and we will come to some questions and answers at the end. Over to you, Rick. Rick, are you still muted?
You muted, Rick.
Sorry, I was muted by the organizer then. Thank you, Ollie. Thank you very much. So the next few slides, we're going to go over the root causes of movement and transport issues. Bernard's touched on some of the statistics. Ollie's given us some real life examples. And we're now going to spend a bit of time just going over root causes and why it's important that we understand the root causes of movement and transport issues. So I'm sure everyone's familiar with the term root cause analysis. It's an often used technique, and we use it to find the primary cause of a problem. So we can determine why it happened, and we can determine what happened and figure out what we do to fix it to stop it happening again. So the first root cause of movement and transport is driver behaviour. So we have a lot of issues with the current driver shortages. That's giving us challenges. Congested roads are causing drivers to having harsh braking incidents more often. And then there's the unexpected causes of issues. The second root cause is road conditions, things such as potholes and speed bumps, roundabouts and corners. And we all know there's factories in the regional areas which have very challenging routes to access them, and this causes its own unique challenges in those factories. The third cause is warehouse and handling. So we have vibration from conveyors and that type of equipment. We see a lot of forklift impact damage, fork damage to the product, and then we see damage and MITs caused by shocks from drops. And this could be either in transport or by the forklift trucks. The fourth point is double stack pallets. This creates compression damage. It can damage the top layer, and this compression can lead to unstable loads. The fifth point is packaging performance. So as we all know, there's a lot of drive currently to lightweight products for environmental improvement. This is causing issues with pallet stability and creating movement and transport problems. There's new materials being developed, such as replacing plastic with paper products. Once again, this is giving us some challenges with movement and transport. And finally, as we all work towards the plastics tax next year, recycled content in products is becoming more common. However, we are finding in certain packaging products that's weakening the product and giving us problems with movement and transport. And then the final point is pallet configuration. So we'll touch on this in more detail later on in the presentation. But the way you stack your pallet can either improve or make pallet stability worse, and this can lead to movement and transport. Weight distribution when we're doing mixed pallets is a very important factor that can lead to issues with movement and transport. And finally, the use of interlayer sheets is something we'll discuss in more detail later on. So with that, I'd like to move on to the next slide. And as we know, we can only eliminate some of those root causes. There's others which we can only manage and minimize, and some, such as the road surfaces and road routes, are totally out of our control. So that brings in really the purpose of packaging, and that is to provide an adequate protection from the unpredictable factors in the supply chain. And it's our responsibility to do that without excessive impact on the environment. So as a supply chain, manufacturers, packaging suppliers, and logistics providers, we are responsible to identify the cause of the damage and get right to the root cause. And then we're responsible to propose suitable packaging methods and materials to overcome those issues, and we must apply them in an optimized manner. So with that, I'd like to touch on testing and how we use testing to identify or to confirm the causes, the root causes we've just discussed. As we all know, there's generally and usually three types of packaging material. We have the primary packaging. That's the packaging touching the product, so a bottle or a pouch or a bucket. Usually that's collated then using secondary packaging, In this example, we have a cardboard tray with a heat shrink collation film. And finally, once that pack's assembled, it's palletized onto the final pallet. And as it's being palletized, we then use the final type of packaging, your tertiary or transport packaging. That's things like layer cards, cardboard corner posts, stretch film, shrink hoods, and all that type of material. That's what holds the goods together in transport. Now, this final unit, as we see represented by the blue square there, that's the overall package. And none of these components can work individually. So primary packaging relies on secondary and tertiary, and vice versa. And so it's very important that we test the overall packaging performance to understand the root cause of our issues. We use a standard developed by UMOS, the 40509 standard, and there's 4 areas we look at when we're testing to confirm causes. The first is load stability on impact. The second is movement between layers. The third is primary packaging. And then finally, the secondary packaging. And as we've touched on before, all those areas need to work together, and they all need to perform in harmony to get ultimate performance out of our packaging. So I'm going to hand over now to Bernard, and he's got a couple of slides on the importance of collaboration and working with the different stakeholder groups to pull together the packaging performance. Thanks, Bernard.
Thanks, Rick. So essentially, there's 2, you may say, large groups involved in supply chain. We speak of the supplier group. This is the group where packaging materials are manufactured. We have raw material innovations, biodegradable products, bio-based products, high-performance films. Machinery for manufacturing packaging materials has come on leaps and bounds. We have, for an example, pallet wrap machines that can produce 55-layer nanofilms. So we have packaging producers that are working with machinery manufacturers and innovative materials, raw materials. And as they work together and collaborate, we speak of this as the sweet spot of packaging innovation, where better products are available to market. On the other side of the coin, we have what we call the user group. We have brand owners, people who are bringing products to market. They have a pride and a passion in a brand that stands out. We have factories, processing plants, manufacturers that are producing product and packaging it for the brand owners, and they are buying their packaging in from packaging suppliers, of which Lindum is one of them. And as they work together, we speak of the sweet spot of packaging optimization. So products are being used more effectively. We're looking for environmental benefits, we're looking for cost benefit, and we're looking for performance improvement in packaging. But what we find historically is these 2 groups actually need pulling together. There needs to be more collaboration in view of actually achieving a successful reduction on MIT. And we as a company believe often environmental or cost benefits are left on the table because there's a resistance or reluctance to try new products because of the implications. And we've identified that really the need to bring these 2 groups together for effective MIT resolution while reducing cost, reducing packaging, and improving performance is to introduce the ability to test, real-time testing on-site, on production lines of new and innovative products. So with that, we'll move on to the process that we've developed. A very simple process. Rick's touched on it already. But what we're saying is there's a need to have a uniform method, approved method of testing to identify the root cause of these MIT issues. Then they can be resolved through innovation and optimizing of packaging materials and products, collaborations between the stakeholder groups, and then retest. So we can then test again and set performance standards and benchmarks for packaging and create a regular audit at step 4 that then kind of keeps a continuous process so that the ground gained and the challenges resolved are maintained in a busy supply chain. To do that, Lindum has invested heavily in the ability to test and the ability to bring that UMOS test center to your door. I'll hand over to Emily, who's got a video that she'll be showing us and then we'll move on with a conversation with Steve Lomax. Over to you, Emily.
Thank you, Bernard. And the next section that we're going to move onto is Steve at Crown Paints. Rick, our packaging technologist, is going to ask a few questions about how collaboration and testing has worked at Crown Paints. So over to you, Rick, and over to you, Steve.
Thanks for joining us, Steve. I appreciate you giving us some of your very busy schedule on what I know is a very busy week as well. So
yeah.
We've done this process at Crown, and I wondered if we could just go through a few points to help the audience on how it's worked for you guys, if that's okay with you.
Yeah, sure, Rick.
That's good. So you've been working on the issue, obviously, of pallet stability at Crown for a long time. Paint, by its very nature, is a tricky product to transport. Can you talk us through some of the early things you did to try and fix the problem, and how did they work for you guys?
Yeah, I mean, early we tried to fix the problem and probably didn't fix the problem. We had a long-term issue with movement in transport with our 10-litre buckets, probably to the cost of £200,000 a year. 10-litre packaging used within the UK industry, certainly the paint industry, is poorly designed, and stacking configuration sits in board of the pallet, creating a gap when loaded on the vehicle. We've used Dunnies bags to try and improve that and close the gap and increase resource by 3 people, 1 per shift. And what we've seen as well, in summer months, we get a huge increase when the higher temperature comes. Plastics get softer, packaging gets softer, the film gets softer, and we get a massive increase in damage. Also, the business has never really seen the advantage of using a quality film. They think film is film, much like, you know, you'd wrap on your sandwiches, or it's just film. They don't see benefit from one film to another film, and so we never really got to the bottom of it. They even tried to set up a working group, but without the facts and the data, they never got anything conclusive.
Okay, that's good. That's really interesting. And how do you currently measure the cost of movement in transport?
Well, the true cost is unknown. We gather our costs via our ordering system, and as I said, average is probably about £200,000 worth of damage a year. But we'd never get a detailed breakdown of the damage. Also, what's not included is a cost. You've touched on it, is recycling, disposal, cost of rescheduling that work, and these impacts on sustainability, all that what we're trying to, you know, achieve now. Finally, the impact of the customer you've already touched on, and our reputation as a business.
So I think we've discussed this number before, but am I right in saying I think we got somewhere between 6 and 10 times the £200,000 was the true cost of moving in transport? Yeah.
Yeah, if you took all them things what I've just reiterated, you know, the actual recycling, the disposing of the waste, and the impacts of remaking that product, yeah, it's much higher.
That's cool. So we've been doing stability testing to get to the root cause. Tell us a bit about that and some of the learnings you've got from that.
I think the key thing, Rick, is with the stability testing, it's data driven, and it's a great visual aid. So it shows key stakeholders within the business then visual results using that UMOS standard, and they see that, you know, they can feel it, and you can see when a pallet is poor, and you know the after effects when you get stability with that pallet. They really buy into that.
Yeah, that's cool. And what's your number one takeaway in terms of pallet stability been from the testing we've done?
I think so. The number one takeaway would probably be that it's getting, key stakeholders involved. People from purchasing don't see that bottom line result. They're key on cost, or if you're in purchasing, you're just trying to get that packaging, as cheap as possible. So to get that visual, description right across the business is brilliant. They're buying instantly.
Yeah, that's good. That's been a key thing for me as well, being able to demonstrate to everyone exactly how it's going to work, and actually seeing them have a solution. So we've identified some major issues, but then on the back of that, being able to actually find a solution.
Absolutely.
So go on, sorry.
No, go on.
So what I was going to say was you've actually seen and used the mobile lab that we have. So
Yeah.
we brought it on site. Just what's the advantages of having something that's mobile and can come to site as opposed to a fixed laboratory?
Well, as you know, we did some testing prior to you guys coming on site, prior to Brexit and after Brexit as well. So at the time before yourselves came to site with the pallet test rig, there wasn't anything available to us. So we searched the UK, so we had to go to Germany. So we went to a tech centre in Germany, and just getting the pallets there in one piece, obviously a challenge, because you want to check your film and your containment on that package. If it's not getting in there one piece, or it's already gone 300 or 400 miles, across the seas and into Germany, that can have a big impact. So we used to have to double wrap, carton, strap, just in hope of getting them, and we'd send more pallets than we needed across to Germany just to try and get them in one piece. Also, Brexit, as I've just reiterated, has added further issues and complications, increased project time, increased costs, increased paperwork. We did all the paperwork, we did it all right, but it was sharing a load with other items from other companies, and that got stuck at the customs. We did all our paperwork right, and it got stuck at the customs on the way over. Having Lindum do the testing on site removes all these issues. Lindum delivered results probably in days that has took us months since Brexit to get to.
No, that's good. That's helpful. And one last question then, which touches on one of Ollie's stories previously. Load utilization. We've been working on getting more product per pallet so that you can improve your truck fill rate whilst solving the problems of movement and transport. What's the benefits going to be from achieving this for you guys?
So as you reiterated there, our standard 10 litre pallet is 48 packs per pallet, and we struggle to get stability on them. Since obviously doing testing with Uri, it's give us that peace of mind. We've got stability on our 48, so we're now doing further testing, trying to increase our number of packs from 48 to 56 configuration, and also a 60 configuration with an extra layer, so we've increased the height of the pallet. And as you know, we've managed to get stability on that using your test rig. So I mean, that's we haven't done the work yet, but obviously the movements, the people, it's a £1 million project saving.
Yeah, and I think that was just a point I wanted to touch on, because obviously we're talking about helping other people here today solve their problems, but sometimes you can get so focused on the transport issue, you become blind to the other savings within the supply chain that can be achieved as well. So that's been really helpful. I think everyone on the call will have found it very helpful. So thank you so much for your time.
Yeah,
and
no problem, Rick.
You've got any other points you'd like to add?
The last thing, Rick, obviously we're all trying to get a sustainable edge now. You know, getting the right amount of film on the pallet, getting it stable, not being able to, you know, not having to deal with that waste and then reproductions. It's just key.
Yeah. No, that's excellent.
Thank you very much.
Thank you very much for your time.
No problem.
Rick, could we, Steve, if you don't mind, could we just show a video of some of the testing that we did?
And I think that shows that the just true visual impact that we get with all stakeholders, you know, people from all different departments in the business, that you know, that tie in to the old package.
Yeah, excellent. Steve, you can give us a bit of commentary on what's going on here.
Yeah, so on the left is a standard hood. This is the one where we put an extra layer on the pack. So you can see the left actually is going over, but the pallet on the right looks like it's not moving, but if you look closely, it is moving fractionally. And that was just the true difference with, you know, getting the right amount of film at the right tension, the right layers. It's just a game changer. And like you guys said before, we didn't have that facility to actually model what happens in transport.
Yeah, no, that's good. That's a very interesting case study, that one, and the one on the left took a while to clear up, shall we say?
Yeah.
Good. Thanks for that. Thanks for your time.
No, guys, thank you.
Brilliant, guys. Thank you, Steve. That was really useful. Just moving on to the next section now. We've looked at some root causes, we've looked at some test and collaboration work. I'm just going to hand you back over to Ollie now to look at effective solutions.
Thanks, Emily, and thanks, Steve. So yeah, I've actually got 4 what we might call hacks or tips that you can take away to try. But to put these in context, I'm just going to show a graph to try and explain how stretch film actually works. Now, this is a very technical looking graph, but put very simply, stretch film is stronger the more you stretch it. And think of it like an elastic band. I don't know if you've got one in front of you. I actually have. And quite simply, when an elastic band is not stretched at all, I don't know if you can see that on my camera, but it's doing nothing for you, and it's still got latent energy within the band, within the material. Now, as you move on to phase 2, you're stretching the material, and it gives some resistance. But when you get right up to phase 3, you'll get to a point where it locks out, and you can't stretch it anymore without snapping it. And that is the point where it is strongest. So that's your phase 3, what you see on the chart there is its sweet spot. And that is the point, the level of stretch that you want to be aiming for in your stretch film in order to maximize stability. So the first hack that I wanted to show you is how to identify what level of stretch that you actually have left in your pallet wrap. So we call this our stretch improvement factor. And so you remember the 3 phases of the elastic band as you watch this video. But start off with, make 2 marks, just 5 centimeters apart. And then you can literally grip the wrap and physically stretch it until you feel it lock out. So you don't take it so far that you break the wrap. And then literally measure how far apart your 2 marks are. So bear in mind, we started at 5 centimeters, and this particular example, it stretched all the way to 14 centimeters. Now, to get the what we call the improvement factor, you simply divide the new measurement by the original one. So in this case, 14 divided by 5, you get an improvement factor of 2.8. Now, the perfect score, if your wrap was already stretched to its optimum, you'd get 1. You wouldn't get any more stretch out of it. So when you try this, it's quite simple to do. If you get anything more than an improvement factor of 1.25, that shows that you've got some room for stability improvement. Now, if you have any problems trying this, my email address is on the slide. I'd be really glad to hear how you get on, and I'd be happy to help. So moving on to the second hack that we've got for you. This simple test shows how to measure how much holding force your stretch film is giving you. So you'll need a spring balance or a fishing scale, and a retention plate, which you'll see in a second. So you need to make 2 marks, as you can see, are done on the pallet there. And the first one has to be 470 millimeters from the edge, and the second one needs to be 250 millimeters from the top. And the 2 marks need to be just 100 millimeters apart. Now, these parameters are set out by the ASTM standard, and we can give you details on that should you need it. Now, how this works, you cut 2 very small holes in your marks. So those 2 holes are 100 millimeters apart. And your retention plate, which is literally just a plate with a small lug attached to it so that you can attach the spring balance, you slip that behind the wrap, and so the lug protrudes through one of the holes. And with my fishing scale here, you attach that to the lug. And the aim of the game here is to pull the disc out to 100 millimeters away from the surface of the pallet. And what we're measuring here is the amount of force that's required to do so. So you see, we're measuring so we can see where 100 millimeters is, and literally pulling the wrap 100 mil away from the pallet and taking a note of the force that's required to do so. Now, in this example, we found that it took 3.6 kilos of force to actually pull the wrap out to 100 mil. Now, there is recommendations on what kilogram force you need, and that depends on how high the pallet is, the weight of it, the stacking pattern. There's quite a few factors that go into that calculation. And if you want us to help on what you should be working to, please, again, reach out to me, talk to us, we'll help you with that. So moving on, hack number 3 comes in the form of a free download that you'll see in the handout section on this webinar. You can simply click on it and download. It is a simple calculator that you can use to calculate how much stretch your wrap is currently being applied at. So your packaging supplier will tell you what percentage stretch a film's capable of. And this is your way of actually telling how much of that stretch you're realizing. It's quite simple to use. So you need to input your data into the yellow cells you can see on the bottom of the calculator there. And you'll need to count the number of rotations on a pallet cycle. And then you'll need to cut the wrap off and weigh it as carefully as, or as accurately as you can. So in this example, I've weighed one and it's 250 grams. And I've put all the details in, and it's come out at the wrap of my pallet was, if I can read it on there, 179%. So if this was a 300% stretch film, I know that I'm only utilizing probably just over half of its capability. So I know that there's extra energy or extra holding force available from that film. So that's a free takeaway you can download. And I will move on to our last hack, which is really to take a look at how product is stacked on a pallet. In this context, we're looking at a boxed product, so cartons of product stacked on a pallet. And we often see the issue of cartons getting crushed, particularly at the bottom of the pallet. And there's quite a misconception that the best stack pattern for avoiding crushing is brick stacked, as you see on the screen in front of you. However, what we find is that when you brick stack, the weight of the pallet is actually distributed onto the weakest point of the carton below, which means that the overall stack is less stable. On the other side, if you go to column stacking, so where everything's stacked in columns, the weight distribution of each carton is spread directly onto the strongest point of each carton below it, improving the stack performance by 25 to 30%. Now, you might find you need layer sheets or corner edge protectors to complete the package, but a review of how you're stacking products can make a phenomenal difference. Now, I'd love to hear how you get on with any of these hacks. Please do contact us, tell us how you got on. We'd really be interested to know and talk to you. But I'm now going to hand over to Bernard, who's going to briefly summarise what we've talked about. And then we've got some questions that I think have come into the chat that we're going to answer. Over to you, Bernard.
Thanks, Ollie. Very, very useful hacks that you've shared with us, and great for giving an indication of what potential we have for improvement. Not a lot to say in summary other than we all have a responsibility to minimize these risks and losses. Don't underestimate what the losses are, as Steve has emphasized for us. But working together, we'll find some quick wins, we'll find some solutions to long-standing problems, and some simple takeaways. Identify and understand correctly the causes of MIT in your supply chain. Correctly apply the right packaging processes and materials to your products. By doing this, you will actually minimize the environmental impact of your packaging anyway. And use recognized and consistent methods of testing. We all hear so often of the transit trial, and it went wrong because the driver drove wrong, or it went wrong because something happened. All of these are very subjective tests, but use recognized consistent test methods. UMOS is an excellent standard to go by. Our mobile truck is available, and I'm sure you will find that the wins are very, very clear as we work together on these challenges. We'll hand over to Emily to run through some of the questions that have been coming in. And thank you again for attending.
Thanks, Bernard, and thanks to all our speakers today. We've had a few questions come in already. I'll just start going through those. One here, what level of transport damage is typical and inevitable? I'll pass that one over to Rick to answer.
Thanks, Emily. We had a discussion about this earlier, actually. So Bernard touched on the 10% statistic. The Newton Centre tells us that 4% of all goods globally are damaged. But we feel very strongly that the only standard is to have no reoccurring instances of movement in transport. So we all know there will be accident and there will be human error. But if something's reoccurring, it should be able to be solved through packaging and innovation. Hopefully that helps.
Thank you, Rick. Another one that's come in, does this testing only work for stretch film, or does it work for cartons and shrink wrapped bottles too? I'll hand that one over to Oliver.
Yeah, that's actually a really interesting question. And the answer is, yeah, it works for all package types, because the main purpose of the testing is to test the entire complete format, including your primary, your secondary, and your transit packaging that Rick was referring to earlier. So the answer is yes, it tests all package types, but predominantly we're talking about the accumulation of all of them, and if that answers the question, Emily.
Oliver, also we used the trial to test stretch hood against stretch film against shrink wrap and prove which was the best media. So we were buying a new wrapper, and we had two directors that thought shrink hood was the way to go, and I'm saying, why would you think shrink hood is, we're trying to be sustainable, you're using gas, you're using more film. So we actually run the trials, and actually we sent packs over from our German plant, which was shrunk. We sent some hood and we sent some stretch film, and we actually proved stretch wrap was the best material from a containment, from a sustainability, everything. So yeah, you can use that same test on anything. Yeah.
That's a good point, that, and particularly with your product, Steve, because it's a heavy product and inherently unfillable, isn't it? Your 10 litres, particularly. That's good. Were there any more questions, Emily?
Yeah, it's just one that's popped through now from Matt. Great to see the simulation equipment available in the UK. Steve mentioned environmental conditions affecting the packaging. Are you able to condition your simulation environment, temperature, humidity, etc.? Rick, is that one for you?
So the answer to that is we bring the lab onto your site. So we'd be testing in whatever environment was on site, if that makes sense. However, yes, it is possible to precondition products and then test following that preconditioning.
Great, thank you, Rick. One more question that we've got here. We always specify a high performance 300% machine stretch film when we retender each year. Could two 300% spec films perform differently? Bernard, you've not answered one yet.
That's an excellent question. I suppose it does bring up the age-old debate about whether e-tendering and tendering is an effective way of sourcing packaging. But without going too deeply into the debate, the answer to that question is yes. Two films with exactly the same specification on paper can perform entirely differently in practice. And without getting too involved in the technical aspect, the quality of the film, the stretchability, puncture resistance of the film is completely dependent on the quality of polymers used and the initial manufacturing processes of that film. And in simple terms, a film that's made from slightly harder polymers could tend to slip over stretch rollers in a pallet wrapping machine, whereas a softer film, more expensive to produce, but will stretch more effectively. And really, whoever asked that question, it's an excellent question, but it just highlights the very important need for real-time testing when trying to resource or improve our packaging performance. Thanks, Emily.
Thanks, Bernard. This one I'm going to direct to Ollie because it's about one of the hacks. In your hack, you showed a measurement of 3.6 kg. Do you have recommendations of what a pallet should be?
Yeah, I wondered if we might get a question about this, because it really depends, which is not a particularly helpful answer. Every product will have a slightly different recommendation, and a different weight product and a different pack format will have a slightly different recommendation. I'll give you an example. Bags of flour weighing a ton might need a force of 10 or 12 kilos, but 200 kilos of neatly column stacked boxes might only need a force of 3 kilos. So it really has to be looked at on a case-by-case basis, but I'd be more than happy to look at that with you, whoever answered that question, if they get in touch, to either Rick or myself on the email addresses on the screen.
Thanks, Ollie. One more question, I'll hand this over to Rick. Do you find that more stretch film is often needed to improve transport stability?
The answer to that one, Emily, is no. So, as we touched on before, often people use more plastic because they think it's the way of solving the problem. And what most of our customers find following testing and actually getting to the root cause analysis is that we can actually reduce the cost of packaging and the amount used whilst improving pallet performance. And this is often because in the case of stretch film or stretch hooding or heat shrink, the product is not optimized to the machine being used. And that means that we're actually, in essence, throwing away wasted yield. Ollie showed the elastic band example, so the film won't be stretched to its maximum strength. And so by actually getting the settings right and using the correct film, we can use less raw material and improve pallet stability. Hopefully that helps that all.
Lovely, thanks Rick. I think we'll just go for one more, purely because we're running up to 3 o'clock. One here. In your experience, is it best to use cardboard layer cards for heavy products, or do paper sheets work okay? Ollie?
Yes. In our experience, we've often found that paper sheets in many circumstances are better. Reason for that is because cardboard layer sheets can actually compress, and you lose the effectiveness of them, whereas paper doesn't compress in the same way, whatever weight you put on it. Probably the most effective option we've come up with is an anti-slip layer sheet, which is one of the examples we used on Steve's product. So it was an anti-slip layer sheet to actually prevent movement between the product. That's probably the most effective. I don't know if that answers the question properly.
Thanks, Ollie. We just wanted to end by, oh, we had another question. Sorry, just want to get them all in before. No, I think we're done. Okay, so just to wrap up then, just want to say thank you for joining us today. The email address of Ollie is on the screen if anyone wanted to get in touch with him after the event. Just a few things. The stretch calculator Ollie mentioned is available as a handout to download on your dashboard. It's there if you want to click on it and download it. If you are interested in packaging audit and testing, contact details are there on the screens. Get in touch with any of the team. Ollie will be more than happy to help. Or if you've got any questions at all about any of the points raised in today's webinar, then pick up the phone and get in touch with one of our team. We're more than happy to help. So just want to finish then by saying thank you to everybody for joining us. Thank you to all our speakers today. We hope you found the